This video is going to go over some examples of where you would use the concepts that we learned in this chapter. So we're going to do some application problems. So if we take a look at the first one here, it says, in a volleyball game, a player on one team spikes the ball over the net. Okay, so we have a volleyball player. So I'm going to draw a picture here. So here's our volleyball net. And we have a player here. And they're going to spike this volleyball over the net. Okay, and it says the ball is 10 feet above the ground, and then the player is going to go down on it, and it's going to spike the ground. It says downward, so we know it goes down, and it tells us the initial velocity and all of that, and then it says the equation h equals, this could have also be written like h of t if we wanted to in function notation, but it's just an equation. It says it represents the height h of the ball at t seconds. So t is the seconds and h is the height of the ball. It says how much time does the opposing team, so it says how much time. So that means find t. It asks how much time does the opposing team have to return the ball before it touches the ground. Well, the ground is h. The height. So if the ball is on the ground right here and h is the height of the ball off of the ground, that would mean that h would be 0 if it's on the ground. It would have a height of 0. If necessary, round your answer to 2 decimal places. So when we read these application problems, you're going to be given the equation. It's much harder if you have to write the equation and come up with it. But in these problems in this chapter, you are given the function or the equation, and you just have to read it and ask what it's and read through and find what it's asking you. So it's saying if the height is 0, so if the ball is on the ground, what would the time be? So this is what we learned in this chapter, how to solve a problem where the variable in the problem has an exponent of a 2. So one thing we could do is see if anything can divide all of these numbers here, which in this case there is nothing that goes into negative 16, 55, and 10. So now to solve this, we could try to factor it, except for we don't want this to be negative if we're going to try to factor, so we should divide everything by -1. But because these numbers are pretty large, I'm going to go ahead actually and use the quadratic formula. So remember that would be negative b plus or minus b squared minus 4ac all over 2a. And that is a formula that you do need to memorize. So negative, so this would be A, this would be B, and this would be C. So negative B plus or minus B squared minus 4AC all divided by 2A. Now we're going to go ahead and simplify this. So 55 squared is 3,025, and then a negative times a negative is a positive, and 4 times 16 times 10 is 640. Okay, and then 3,025 plus 640, that would be 3,665. Now it says, if necessary, round your answers to 2 decimal places. So I want to see if this can be simplified. It's a pretty large number, the square root of 3,665. Nope. So because this can't be simplified and it tells us to round our answer, put our answer as a decimal, it doesn't say we need an exact answer. We're going to go ahead and put this whole thing in our calculator, so follow along with me. We're going to do negative 55 plus the square root of 3,665. Then I'm going to click equal. If you don't click equal, you'll get the wrong answer because you need this whole thing in parentheses since it's all in the numerator. So I'm going to do it in two parts. I'm going to click equal and then divided by negative 32. And if I do it that way, I won't need parentheses. Okay, so we get about, it says round to 2 decimal places. So that means we need 2 numbers, but we need to go to the third. Okay, so it's about negative 0.17. Now we're going to do it again, negative 55 minus, so negative 55 minus the square root of 3,665, click equals, and then divided by negative 32. And we get 3.6106, etc., etc. We only want 2 decimal places, so we look to the third number. It's not 5 or higher, so it's about 3.61. Now, what we just found was t. And t is the seconds. So we can't have negative seconds. So this is going to be extraneous here. And then we're just going to have this answer here. So it says, how long will the team have? How much time does the opposing team have to return the ball before it touches the ground? So we would say the opposing team has about, because it said to round it, 3.61 seconds before the ball hits the ground. Okay, or it has about that long, and then it will hit the ground. So think about what that negative that we got represents. So this negative here would represent when it's on the ground over here. But because it says the person is going to spike it down, we know it's not going to go back over here. So that negative answer we got is like over here. So we don't want to include that. So that's what it means in the picture, but it doesn't, we're not, in the context of this problem, it is not a solution for this problem. So again, here's our answer.